Hi, good evening and good morning to all of you. Today we are going to discuss on very high level what exactly is Docker and what exactly is the relationship of Docker with virtual machine. And then I'll show you practically how we can create some Docker containers so that you understand the real-time benefit of Docker. Of course, it's not an entire course, but a very good beginning for anybody who is absolutely fresh, who have no prior knowledge of Docker. For those people, I would suggest this is one of the best entry point into the world of containerization. So as I begin, before we actually get into understanding Docker or let's say containerization, we have to first understand what is virtualization. What exactly is virtual machine? See, honestly speaking, in this world today, when we are working with cloud computing, virtualization is not something new. We have been very frequently creating virtual machines, and on top of these virtual machines, we have been installing the required softwares, which can be our web based applications, which can be console based applications, which can be services. Various types of applications we install, we use them as and when needed, persist data, and so on. But actually, how is virtualization created? See, in the past, we talk about, let us say, absolute basic computer, which has all the required hardware, let it be your processor, memory, storage, network card, mouse, keyboard, CPU, whatever, entire hardware, which is completely managed by an operating system. The operating system can be Linux, the operating system can be Windows, the operating system can be Mac. The operating system is supposed to have a list of drivers. We call them as device drivers. Yeah, the generation today is very lucky. You don't really bother a lot about device drivers. Most of them are like plug and play. You connect a computer with the printer and you start using the printer. Rarely you need to actually install an additional driver. But those days when I started my career, at least sometime in 1992, 95, 93, 94, the operating system was DOS. It was really a challenge to install the device driver and make the device work on the computer. Of course, with the advent of Windows 95, that was in the year 1995, things became little easy. The device drivers became plug and play, and then we were able to simply attach a device and install the driver with few clicks here and there and make it work. And then things only became easy day by day. And today, most of the people don't even know that the operating system layer in background uses a device driver which is responsible for converting the high level instructions of the operating system into the low level instructions understood by the hardware, and of course vice versa, reverse also. And on top of the operating system lies our application. These applications are one what we have developed. As a .NET developer, you might have built some application. As a Java developer, you might have built some application. Or maybe C and C++ if you are a legacy developer. Or Python application. Some kind of applications which you might have developed on top of an operating system. So how does this whole system work? The application which we developed, let us say I used C programming language. To do something, I will write my code and I will invoke the API of the operating system, application programming interface of the operating system. That means my application makes call to the OS libraries, and these OS libraries facilitate converting our instructions into the hardware understandable format with the help of device drivers, and at the same time they take our instructions into the processor data on the disk, and like this the entire system is working. So the applications which we build are always specific to the operating system, like C and C++ applications specifically, because the C and C++ instructions are tightly coupled in machine code format with the operating system. Java, .NET now, Python, PHP, these are not OS specific instructions. What they do is, on top of operating system, they build one more layer, which they call it as a runtime layer. If it is Windows, this will be Java runtime for Windows. If this operating system is Linux, it will be Java runtime for Linux. If this is Mac, this will be Java runtime for Mac. And this runtime, which is very specific to the operating system, will then be responsible for converting the instructions which we compile, let's say from Java source code to Java bytecode, and the bytecode instructions will be compiled by Java runtime into OS specific, and OS specific instructions will further go down to the hardware and execute. So these languages, Java, now .NET Core, Python, PHP, all this we put it under the category of platform independent programming languages, for the reason that they are not tightly coupled with the operating system. The compiled output of Java, called as bytecode, the compiled output of .NET, we would call it as MSIL code or IL code now. Likewise, we do have PyCode, Python compiled output. All these things require the respective runtime. And the respective runtime, which is tightly coupled with the operating system, will take care of converting from one format to the other format and execute. Blah, 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 blah story. Not really interested in that. Point is, if I use, let's say, .NET for development of my application, I might do development in .NET Core 3.2. So I need .NET Core 3.2 on every machine where I should execute my application. Or if I develop today, let us say in .NET 7, I would need .NET Runtime 7 on every machine where I would like to execute my application. That means our application which we have built is pretty much dependent on the runtime which is required for execution of that application. And that too, the compatible version is needed. Fantastic. Likewise, same is the case with Java. You might use Java JVM, and there are different versions of JVM. Python also has got version 2, version 3. Lot of things which are built on Python 2 are not compatible with Python 3 because that was a revolution which came. Point is simple. Every application has certain dependencies, and those dependencies are needed as it is. Without those dependencies, our applications are not going to work. So how do we handle this situation? What if my machine requires Python 2 also, Python 3 also, .NET Core 3.2 also, .NET Core 6 also, .NET 7 also? I want to run all the applications. There will be definitely chaos. There will be definitely a lot of incompatibilities, which can lead to a situation where some application was working already on this particular machine. I installed another application, and that application needed the latest libraries. So on installation of latest libraries, imagine the old version libraries got upgraded, and the new application now starts working. The old application will stop working. This can be a typical situation where we ended up upgrading our applications, new version, but some of the old versions will stop working. Radical problem to see, which a lot of people face in the industry. How can this be resolved? Simple. Let's say, take a virtual machine. What is a virtual machine now? I would say a virtual machine is nothing but a software machine, a hardware being treated like a software, and with the software we'll create a virtual machine. So ultimately we will have all the hardware here. Let it be CPU, RAM, processor, all that hardware will be there. On top of that hardware, we are going to implement virtualization. We are going to use something like virtual machine monitor, VMM, which can be Hyper-V, which can be VirtualBox, which can be VMware. There are a lot of virtual machine monitors. So these, in generalized term, I could call it as hypervisor. These hypervisors are what I'm going to use for building these virtual machines. Every virtual machine will reserve some hardware from the host. Host is your base, physical hardware, and then there is a virtual hardware which every virtual machine will have access to. So let us say I've got 64 GB RAM on my physical hardware. I may create one virtual machine with 16 GB. I may create another virtual machine with another 16 GB, and these 16 GBs are reserved for the respective virtual machines. And the applications which are going to be installed in one virtual machine will also see that it has got its own guest operating system. So let us assume that we are working with something like this. We are working with the hardware on top of which some hypervisor is installed, and on top of this hypervisor direct virtual machines are created. These type of virtual machines are type 1 virtual machines. The alternative solution is we have the hardware managed by some host operating system, which can be Windows server, which can be Linux server, and on top of that host operating system we will have hypervisor, and that is when we can manage the virtual machine. The difference is here we do not have the host operating system, here we have the host operating system, but in either case we are going to have an hypervisor, type 1 hypervisor, type 2 hypervisor, and on top of these virtual machines are created. Beauty is what? Every virtual machine can have its own applications. Every virtual machine can have its own dependencies. And every virtual machine also will have its own operating system. So here I might have a host operating system which is, let us say, Windows, and on top of it I'll create a virtual machine in Linux, or I'll create a virtual machine using Windows. In a Linux based virtual machine I will install all Linux based applications, and on a Windows based virtual machine I will install all Windows based applications. That means on one physical hardware we are able to have different operating system environments. Yes, every virtual machine is isolated from the other virtual machine. Every machine is isolated from the other. There is no overlapping at all. Windows will have its own network and IP address. Linux machine also may be part of the same network but will have its own IP address. And because the guest operating system is absolutely different, every virtual machine will have its own file system. Suppose this application in this virtual machine uses the file system that belongs to this guest operating system, and the other virtual machine will again have its own guest operating system and its own file system. The files of one VM do not in any way overlap with files of another VM. They are absolutely independent of each other. That's the beauty. So like this, when virtual machines are independent, there is no overlapping. Applications with different versions, different runtimes can independently work within each VM, and there is absolutely no problem. Good. Very similar concept of this is what is virtualization. Here also we are going to have a host operating system. On top of the host operating system, we will create a Docker engine. And on top of Docker engine, we'll have some dependencies. Ignore this for a while. And then we are going to create containers. Like virtual machines are created from VM images. For every virtual machine, we need something called as VM image. Something very similar is what is needed for containers also. For me to create a container, we need a container image. So if I write in simple layman's language, I have a VM image, and from the VM image, I'm going to create a VM instance. Like that, we can say today we have got container image from which I'm going to create a container instance. Generally, people refer container image as simple image, and container instance as simple containers. That's it. That's a short form. Container instance is a container, and the container image is a is referred as image. So we need an image. Now this image I'm saying is very similar to the image of virtual machine. What is that a virtual machine image will have? Every virtual machine image is supposed to have the base operating system, which can be Linux or which can be Unix, which can be Windows or any flavor of Linux. And on top of it, you might probably install certain software. And then you create an image out of it. So when I create a VM instance, all that software which we installed in the image is going to be part of the VM instance. Say for example, I create a base machine with Windows 2022 server, and on top of it, I install SQL server. And then I create an image out of it. From that image, if I create a virtual machine, I will have SQL Server software ready in that virtual machine. Likewise, here also we are going to have a base image on top of which we are going to install our application, our software, and then create an image out of it, custom image we call it, and then from the custom image we can create container. One image can have multiple container instances if needed. In a layman's language, if I explain, I can have notepad.exe. This notepad.exe, I can create an instance and that becomes a notepad instance. This is one notepad instance. Notepad.exe was launched and that became one notepad instance. I can create one more instance of notepad.exe. This is one more instance. So these are Windows based applications for which we are creating multiple instances. Like that, in Docker world, in containerization world, we are going to find an image from which we are going to create multiple container instances. Yes, that is what is the containerization all about. But the question is, when virtualization is already there, what is the benefit which containerization is going to provide? When we create a container, every container is again isolated from another container. Every container is going to have its own file system. The applications running in the container, if they create some files or write something into those files, or if they use certain files, these are isolated from the entire file system which would be created for another container. Absolutely independent. No overlapping at all. So when container file systems are independent, can I have the same benefit what I got with virtual machine? I can have one version of my application, let's say .NET application, which I developed in .NET 3.0 or 3.2. I will put in that container all the runtime files which are required by .NET 3.2 application. And when I have .NET 7 application, the .NET 7 runtime will be separately packaged into a separate image. .NET runtime 3.2 one image, .NET runtime 7.0 another image, no overlapping at all. Respective images would be used for building the respective images with our custom application. If I explain in little more detail, I would take the base image for, let's say, .NET 3.2 and top of it add my custom application. And what I'll get is a new image. This I'm saying is base image of .NET 3.0 custom application. What is custom application? The files related to the application which I have developed, the binaries of my application which I have developed, and that becomes a new custom image which has my application. And from this image I am going to create a container. Like that, there can be a base image of .NET 7.0 plus in it I'll put the application which I have developed in .NET 7.0 and I'm going to create a new custom image. Of course, that will have a different name, and from that I'll create a separate container. Is there any overlapping? No. Treat every container as a process by itself. This container runs absolutely independent of this container. This container will have its own file system, which is constructed from this and this. This container will have its own file system, which is constructed from here, which is based on this and this. And they're absolutely independent. They don't see internal view of each other. So because of containerization, we are able to run the application with ease, as it has not only the primary application files, but also all the dependencies which are required for my application to run. Actually speaking, this base image of .NET 2, how was it built? That base image of .NET 2 probably was built with the base operating system and all the runtime software required for .NET 3.2. Likewise, here also we might have the base operating system and then the runtime software of 7.0. So layer by layer images are actually built. I'll talk a little more about it later, but point to understand is containers are isolated from each other. Containers will have file system as defined by the image from which the container is created. From same image, we can have multiple container instances created. Even then they are isolated from each other. A container will have its own IP address. Every container will form a network with other containers on the same machine. So basically, am I not talking the same language which I would do it for the virtual machine? Absolutely yes. Whatever I'm saying for the virtual machine, same thing I'm putting it for the containers also. Then what is the difference? Huge difference. If you look at the diagram itself, a container does not have an operating system of its own. A container will only have an application and its dependencies, but it doesn't have the OS patch. Now the big question, what could be the question? How will the application run without the operating system? Yes, the containers are built in such a way that for all their operating system requirements, they are going to use the host operating system kernel. The kernel where actual instructions are executed will be sent to the host operating system. That's why I said earlier, you should treat every container just as a separate process. And because they are using the host operating system kernel, can I say they are very lightweight, as they don't have to load the operating system and the libraries which are used for running the application, unlike as in VM. VM is heavy. Imagine if I have 16 GB reserved for 2 virtual machines out of 64 GB, 32 is gone. And I'm left with only 32 for the host operating system applications. And I can't use that extra memory, that memory, even if it is unused by the applications which are running in that VM, because that is reserved. VM will block it. Unlike that, the container will give us the facility of using what is needed, and of course also giving us the ability to restrict to a particular limit if in case needed. I would say yes, maximum 16 GB, but container might use only 10 GB. Container might use only 8 GB. The remaining can be used by other containers. Container will not block that amount of memory which I have capped for a particular container. Cap can be provided, but there is no lower limit. So yes, very, very important, containers are lightweight. Containers are as good as virtual machine, but they don't have operating system patch. That's why they save lots and lots of memory. If I have 3 virtual machines, 3 times the same patch would repeat. 3 times the memory is invested for every virtual machine, separate patch. Oh, that's expensive. That wouldn't happen in case of container. The same host operating system kernel will be used, though the files will be different. But this leads to one limitation, and you should clearly remember this. I can have host operating system Windows and create a Linux virtual machine, and this application then can be Linux based. I can have host operating system Linux, create a Windows virtual machine, and then this application can be Windows because it has the corresponding guest operating system taking care of all the low-level instructions. And through hypervisor, they're going to the hardware and executing it. In containerization, it's not like that. If the host is Windows, you can only create containers which were built for Windows from images which were built for Windows. If the host is Linux, you can only create these containers which are Linux based. The images, when they are created, they have to be Windows based or they have to be Linux based. Very clearly, I'm repeating, images when they are created, at that point of time, we have to be very clear, is the image for Windows or is the image for Linux? A Windows image will not work on Linux, a Linux image will not work on Windows. They are very much native. This is one of the confusion which is probably there for a lot of people, that containers are platform independent. No, containers are always specific to the platform for which they are built. Is definitely not a replacement for virtualization, but very similar to virtualization. Virtual machines are unique, isolated. Containers are unique, isolated. Virtual machines will have their own file system. Containers will have their own file system. The directory structure of one container will not be visible to another container. So is the case with virtual machine. Virtual machines will have unique network identity. Same thing with container. They form network. Applications from one virtual machine can communicate with application in another virtual machine. So is the case with containers. The application in one container can communicate with application in another container. Application to application communication can happen. I can have my web application bundled in one container and my database application bundled in another container. I can do that. And the web application, by way of connection string, which includes the IP address of the other container, can talk to the database container. Though they are very similar, containers do not replace virtual machine. In most of the situation, it may happen today, especially in the world of virtualization. When we move to cloud like Azure or AWS or GCP, we actually create virtual machines, and inside those virtual machines, we'll create containers. The host can be virtual machine, but in addition to that host, there can be containers created. That's the beauty we can actually enjoy today. Yes, containers are the future way of developing and distributing applications so that the life becomes easy, as we don't have to take care of the dependencies, as they're all bundled together in a common image. So that's why I say container is nothing but virtual machine minus guest operating system. So what is Docker? Docker is the leader. Docker is an organization actually. Docker now can be said as an open source platform with which we are going to implement containerization. Are there competition to Docker? Yes, there are competitions to Docker. We do have substitutes to Docker also. So what is Docker? Here I said we need some engine, like hypervisor is there. We will need some engine. That engine can be a Docker engine. So Docker is an open platform which I'm going to use on a dev box development, which I'm going to also use for shipping of my images and also to create running applications which are nothing but containers. So Docker is a way to implement containerization, and Docker is so popular that containerization and Dockerization is same. They are like synonym in the industry. Most of the time when you're implementing containerization, you're actually implementing through Docker, though there are alternatives. So Docker enables you to separate your application from your infrastructure so that you can deliver the software quickly. How? What we are going to do is, as a developer, I'm going to build my application. Understand this very carefully. If I'm a .NET developer, I'll write my code in .NET, build the entire application, test it locally, ensure that everything is working fine. Likewise, if somebody is a Java developer, somebody is a Python developer, they would also ensure that their application is working absolutely fine locally. And now they want to distribute this application, and that is the point when they are going to implement containerization for their application. How? They are supposed to write something called as Docker file. See, every development language has certain process to convert their source code to the binaries and then to the machine code executable format to execute them. Let it be .NET, let it be Java, let it be Python. There is a procedure for build and execute. So this procedure of build and execute, I'm going to implement through a file called as Docker file. An instruction set through which we are going to build a Docker image. So I, as a developer, I'm responsible for writing a Docker file. And using that Docker file, we will convert our entire application into a Docker image. This Docker image, I'm then going to put it into a registry. What is registry? Think of registry like your Play Store. You have Google Play Store and iPhone Store, iStore, where on your mobile you install your applications from. But somewhere some developer has put the application there, right? So what we are going to do now is, there is something called as Docker registry. There are many Docker registry. One which is very commonly used is Docker Hub. Docker Hub is a registry where after I build an image locally, I'm going to push it into the Docker Hub. Once I push the image into Docker Hub, from Docker Hub, others can download the image into their local registry. That means on every machine where we want our application to run, we have to set up Docker engine. That means some software has to be installed, which is nothing but a Docker software. So once we have a Docker application installed on our machine, we can download those images and run those images by creating containers locally. Maybe by the end of this session, I'll demonstrate that entire life cycle to you. How you can take the base image, on top of it, add your own custom files, build a custom image, upload into Docker registry on another machine, maybe download it and create a container and use it. So distribution of Docker application is so easy that it's only involved pushing an image into the respective registry. And once it is moved into the registry, from there, on whichever platform you want, basically whichever environment you want, you can download and use it. So in context of benefits, yes, very resource efficient. As I told you, there is no OS. The kernel of the host is going to be used. And because the kernel of the host is used, the applications are very fast. They start up also very fast. They don't have to load the OS. If I have to create a virtual machine, I'll have to wait 2-3 minutes. Docker applications will just start. They are fast and consistent delivery of your application. Once an image is built, you can simply take the same image and deploy wherever you like. And the entire process of constructing an image, deploying into different environments, testing, moving forward, can be automated through a DevOps practice. So modern applications which are mostly implemented through Agile are now implemented through containerization, distributed through containerization. So yes, if you are a developer, you're going to write code locally and share the work with the colleagues by using Docker containers. That means you're going to construct a Docker image, upload the image into the registry, and then once you upload the image into the registry, you can download the image in different environments. Let it be dev environment, let it be test environment, let it be QA environment, or let it be UAT environment, and then finally maybe into the production environment. Same image is going. Because it's the same image, can I say we will bring consistency? It's not that we'll have to reconstruct the environment every time by installing the individual software. No. And that makes things much easier when it comes to Docker for distributing applications through a DevOps practice. And today Docker is so popular that it is implemented on Mac, Windows and Linux. There is something called as Docker desktop software. Yes, of course, until this January to 2023, it was absolutely free. Anybody could just download and install Docker desktop. But nowadays, Docker desktop is supposed to be purchased, especially when you're working for a large organization. There is a number, maybe I think 300 plus employees if an organization has, or if they have some turnover beyond one particular number, that organization compulsory should buy license for Docker desktop for their developers. But if you are a small organization or medium organization, less than that limit, whatever limit they have put, you can still use Docker desktop absolutely free. So if you are using by any chance Windows box or a Mac box for development, Docker desktop is the best choice you can install on your machine. So question can be, Sandeep, Mac OS. So do you think Mac supports Dockerization? Actually, no. When we create Docker images, they are either Windows images or they are Linux images. There is no concept of Docker images for Mac. Yes. Docker images for Mac is not there. Mac, Windows 10, Windows 11. All these are operating systems for desktops. Docker primarily is targeted for applications which run on server. Something like a web server based application or a service which runs on the server which can be consumed by multiple client machines, client applications. Docker is never used for desktop applications. For example, Notepad, Paintbrush. No, you'll never use Docker for these kind of things. Docker is primarily for server-side applications. That means server operating system. Windows, Linux, Windows Server, Linux Server. Maybe different versions of Linux. Let it be CentOS or let it be Ubuntu or whatever. But only for server we are going to have Docker-based application, not for client-side GUI-based application. Be very clear. Then what is the role of Mac OS? Whether it is Mac OS or Windows 10 or Windows 11 today, we can install Docker desktop as a developer. But when we are building the image, compulsory we have to build the image for the Linux or Windows. Mac supports, Mac OS Docker desktop supports creating images for Linux. So what it does, Mac OS on top of it creates a Linux virtual machine. And for this virtual machine, it will create images. Windows has an advantage. Windows 10, Windows 11, if you are using, you can build images for Linux as well as for Windows Direct. So and you have a switch. For example, on my machine, I have Docker desktop. This is Docker desktop. I've already installed. So if I right click on Docker desktop icon, you see there is an option to switch from Linux to Windows containers and Windows to Linux containers. So when I'm on Windows here, that means My configuration currently is Linux. How does it work on Windows Linux images? WSL. Windows subsystem for Linux. Windows 10 is the base. On top of it, we will have WSL. And this WSL layer will be used for constructing images for Linux, though the base operating system is Windows. But when I switch to Windows container, the WSL layer is gone and we directly build images for Windows. So yes, if I can show you, I right now go to the command prompt and type a small command docker version, and you'll see that here, this is Docker engine. A Docker engine is going to have a server-side component. Docker engine is going to have a server-side component, which right now is Linux and AMD 64. Whereas you see Docker client is Windows box. That means Docker client is directly running on my Windows machine and is going to talk to a Docker server which is running in WSL, which is Linux based. A WSL layer is added on top of Windows. Now let's see what happens if I switch. Right click, I'll say switch to Windows container. The moment I switch to Windows container and again execute Docker version, now you see Docker client still remains on Windows, but Docker daemon, Docker engine now has changed to Windows. So my Docker client is same. Same Docker client will send instructions to either Linux or Windows based on how I have configured it, and I'm able to switch from one platform to the other platform for constructing images. Images which I build when I'm in Windows mode will not work on Linux. Images which I build in Linux mode will not work on Windows. They are respective operating system specific because the kernel is supposed to be of the host operating system. So yes, Docker Desktop is a special software on Windows which will let you to build images not only for Windows, but also it will let you to build images for Linux with the help of WSL. That's the beauty of Docker Desktop. Then we have got server. Yes, Docker server can also be installed on, this is the production actually. The production version is always Docker server, Linux distribution or Windows server distribution. For development, we might use this, but for production, we are always going to use a Docker server software on the respective server operating system. Beauty is today, if you're working with some cloud, maybe Amazon AWS or Google GCP or Microsoft Azure or IBM or any other popular cloud, you will see that Docker is provided there also as a service. And most of the time it is platform as a service. How does it all work? Open Container Initiative. OCI we call it, is an open governance which actually Docker only created for express purpose of creating open industry standard around container formats and runtime. So Docker started this OCI so that anybody should be able to create images. So in that there is a runtime spec and there is an image spec. And this is common. This is common. That deals with containers in the abstract way. So you have, as I said, equivalent of Docker, like Podman is one very popular alternative to Docker. The closest possible alternative to Docker is Podman. And then we have got RKT and Mesos. All these are pathetic. Podman, I would say probably lot of people would use alternative to Docker. But others are not at all close, pretty far. So yes, Docker is the leader in the industry for implementation of containerization, though we have got Open Container Initiative and that can be implemented through other vendors too. So let us go a little more closer to Docker and understand its architecture. Docker engine, basically it's a client server application. We have a Docker client and we have a Docker daemon, Docker server, Docker engine. This is where all the Docker instructions are going to execute, but somebody has to give those instructions. That's where the Docker client CLI is going to be used. Docker command line interface. So there are 4 components in Docker: images, containers, volumes, network. That's all. These 4 things make Docker. Entire lifetime of the Docker is only these 4 things. So we are going to use these commands. These are all Docker CLI commands. Docker build, Docker pull, Docker run, and many more. These all instructions go to Docker daemon, which is on the host, and the daemon will then execute these instructions, which can be to pull an image from the registry internet, put it in the local registry of images, and then use that image if required to create a container, one or more. And then these containers are the place where our application is running. So entire management of images, containers, volumes, and network is taken care by this daemon. Yes, if you want, you can configure a Docker client to talk to a daemon either on the same machine, or it can be also on a different machine on your network. You can do that. It's pretty much possible to do that. Docker daemon listens to Docker API request and manages Docker objects. What are these images, containers, volumes, network? I told you already about image, a self-sufficient packaged application, which includes our primary application files along with all the dependencies, including the runtime which is required, as well as the OS related files, is what is an entire image. From this image, we are going to create containers. One or more containers can be created from a given image. Where are images? They're all going to be stored in the registry. From this container, we can see that our application is running. Between the containers which are running, a network will be created. A virtual network is created between all the containers which are running on that machine. We call it as a bridge network. But then there is a problem here. The containers have their own file system. I have been saying that. And that's how one container becomes isolated from the other container. But unlike in virtual machine, the container file system are in memory. They are not on the disk. They are just in memory. And suppose if you stop your container and delete your container, entire file system is gone. All the data will be deleted. All the files will be destroyed. Container file systems are not automatically mapped to the persistent disk managed by the host operating system. In case we want to do that, we will have to bring data volumes into the picture. With the help of data volumes, we are going to persist some folders of the container file system on the host machine operating system managed disk. So even anything on disk is persistent. Your hard disk. It can be HDD, it can be SSD, some disk. So once the data is persistent on the disk, yes, let the container get destroyed. Let the container recreate. We will mount this disk file system back into the container, and container would be able to continue from where it left. Container file systems are not persistent, unlike virtual machine file systems, which are persistent because it has its own host, and that host takes care of handling its own disk. That's the beauty, which is not the case in containerization. So data volumes is the concept used for managing the persistency of the files in the container. Without this, they're all temporary. So now that we understand all this, you see this is how actually the Docker commands can be depicted. You've got Docker file using which you can build a Docker image. You can tag a Docker image with an alias name, duplicate name. You can push a Docker image. You can pull a Docker image from the registry. You can save and load images locally in some tar files. You can run from an image a Docker container. You can start a container, stop a container, and most important, the container is going to host an application which probably is changing the file system of the container. And finally, the container can be committed to create a new image. All this said, let us see now a simple small example of how we can make use of containerization for creating, how we can make use of Docker for creating containers, working with images. I may not be able to take all the demonstration, but yes, to the maximum extent, whatever is reasonable, I'll give you few commands over here so that you have a practical look of it. So I go to the command prompt. So these are all different Docker commands: Docker version, Docker pull, Docker images, Docker run, Docker peers, and so on and on and on and on. So let's go to command prompt. There is a Docker image ls. You see there are some two images and these are all Windows images. I'll switch to Linux. Switch to Linux container. And the same command now doesn't show me any image. So there are two Windows images which are Windows based and I don't see them when I switch to Linux. Because now my Docker daemon is running in the WSL layer. Let's say the virtual machine layer. Whereas in the former case, it was directly running on my host machine. So now Docker image ls, no images. So let's pull. I directly pull an image called as nginx. Where is this nginx image going to be pulled from? Docker hub. And I'm pulling the latest version of nginx. See, layer by layer, every image is made up of multiple layers. All the layers of nginx are being pulled on my machine now, and they will be saved in the local repository. It will take just less than few seconds, maybe 30 seconds or odd, and you'll see we'll have nginx image downloaded. I'm going to use this nginx image for creating containers and then access those containers through the browser, the application which is going to run. What is nginx? Nginx is a web server. The default installation of nginx has only index.html. I don't have other files, but the index.html is what I'm going to use here to demonstrate the output of nginx. Fantastic. Now type docker image ls and you'll see nginx is there. Every image has a name and a tag and an image ID. You see, this is nginx latest version. I can do docker pull nginx maybe 1.19.0. That's a separate version of nginx. Some of the layers probably are already there. See, download complete. Because those layers probably are already there. They don't even have to be downloaded. Extra layers are getting downloaded. Like that, there will be nginx 1.20 separately. Nginx, where can we find all this? You'll have to go to Docker Hub. Go to docker.io. You have to log in with your identity. Once you're logged in, I've already created my account here. Once I'm in, I can search Nginx. And you see, this is Nginx image by Docker themselves. But there can be other people also who are providing Nginx. Bitnami Nginx, unit, ingress controller, all these are different Nginx. You can search for httpd Docker official image by Docker. So these are all public images. So I have Nginx. Now if I look at Docker image ls, you'll see there is a latest version and there is also a 1.19, and you can actually go to Docker Hub, search for Nginx, and here you'll find all tags, different versions, latest for Linux, stable Perl, colon, we can give like that, latest, Nginx colon stable Perl, Nginx colon stable bullseye, and so on and on and on. You can go to overview. Here also you'll find 1.23.4 is the latest. That's the latest. So these are all, you have to search for your relevant image, you have to search. Now once you have the image there, use now Docker run. I want to run in detach mode, -D. And I want to do something called as port mapping. On my host machine, 8080 port, I want to map to port number 80 of container, which is going to be created from Nginx. So this has now created a container asking for some permission, my firewall. I just say allow access because I know I trust. Now you see Docker PS, there is a container running. Just few seconds back it started. And this is the container ID. Now I know container ID and there is also a name, boring whiles. Either I use ID or I use name and get the details of the container. I can do something like Docker inspect, and let's say first few characters of this, if I type, it should be sufficient, 64D, 6D4. Docker inspect, and entire output, I don't want to get into details. Here I see the IP address. This is the IP address given to the container. But where is this IP address? It's in the bridge with the WSL. Because I'm using Linux, I have the base Windows, on top of it WSL, and on top of it this container is created. So my host cannot see this IP address. I cannot copy this IP address and directly paste it in the browser and get the output. No, it will not work. But if it was a Windows container, I would have got this output, because then the network was created directly with Windows, not with the WSL layer. Now, if I want to use that, what shall I do? I did port mapping. I did port mapping on host machine 8080. If I send the request to, it will automatically go to the port number 80 of the container. That port mapping I have taken care of. So I can go to the browser and there type localhost colon 8080, localhost colon 8080, and I'll get Nginx output. Likewise, I can comfortably run here Docker run -D -P, let's say 8090, I'll map to 80 of HTTPD, which is another web server. That image is not there, automatically it will be downloaded. And from that image, the container will be created. Docker run is the command which will create the container. And this HTTPD, if I want to access, I'll go to localhost and type 8090. 8080 is for mapping forward, port mapping to Nginx. 8090 will be mapped to just do docker ps. 8090 is mapped to httpd and 8080 is mapped to nginx. Let's go to the browser and verify. I'll open new tab, localhost colon 8090, and it works. It works is the default output which comes from httpd. See the beauty. I can give here /index.html. I still get the same output. Rather, index.html is the only file which is there in default installation of nginx. Very quickly, I want to get into showing you, demonstrating to you how we can create our own custom images. Let's say I create some folder docker. I use VS Code. I create some small HTML file. Let's say demo1.html. This is demo1. That's it. Let's also create demo2.html. This is demo2. Save it. Save both the files. Maybe I can provide a link to demo2. Small, something similar I do in demo1. demo1.html. So this is demo2 linking to demo1.html, and this is linking to demo2.html. That's it. I want to add these two files on top of that nginx. How will I do that? Not going into a lot of details. I'll have to add to my project one Docker file. From that, I'll take a base image, which I'll say nginx is what I want as the base image. And I would like to do copy of everything from the current directory into the default directory, which is working directory /user/share/nginx/html. Actually, that is the default directory for nginx in the container. And there I would like to copy everything. Maybe I would like to also here itself create one more file. This is testing, but redirect the output to current directory /test.html. So echo is a run command. Save this and now go to the command prompt from the same folder where we have all these files and do docker build -t, let's say my web app version 1 and some dot. There's a syntax which I'm not getting into the details, but yes, my image should be ready. Docker image, and you see now my web app v1 is ready. Can I run this locally? Yes, why not? Let's say docker run -d -p 8091:80, and I'll say my web app v1. Cool. Now go to the browser. Type here 8091. Default page is coming. Try demo1.html. Wow, demo1.html, demo2.html. I'm able to switch. I forgot to mention here title. This I want to be used as title actually. And same thing here. Modified. So what shall I do now? I may do probably rebuild, and I'll say this is version 2, version corrected. I'm taking now version 2. Now if I want, I can run 1991. I cannot because that's already blocked. Now go to the browser. Change this to 1992, 1892. Did I not save the file? Oh, I didn't save the file. My mistake. Whatever. Demo 1. I didn't save those files then. But anyways, you understand. We can save, rebuild it. Now I have a lot of containers running. I can stop all these. Docker stop db09896d. What are all these? I just used first 2 characters of the IDs. They're all stopping. None of these sites are going to work now. This will not work. This will not work. Because the containers are stopped. So I have docker build -t v2. v2. So I should use docker run v2. Last time I did v1. That was a mistake. Let's say 8090. Cool. Now go here. 8090. And fantastic. I'm able to switch. So this is how we build our own custom images. Now how do we push it? I have already created my account in Docker Hub. Docker.io. I have already created my account and I sign in to that account. So here I would like to put my own custom image. For this, Docker push, whatever name we have given, my web app, let's say v2. I'm pushing it. Now, ideally, I'm supposed to do Docker login first because on this machine, see, it could not push earlier. Now let's try to push it. My web app v2. It's not allowing me to push an image. Docker push. Okay. Now the requirement is there's a naming convention which I'll have to follow. I can't push directly with a raw name. It should be prefixed with my identity. So what I'll do is first I'll do Docker tag my web app v2. I'll tag it to with my user ID / my web app v2. We have to tag it. There is a default naming convention which we'll have to follow for pushing an image. Now I should be able to push without any problem. And that Sandeep Soni there is nothing but the login ID. Now you see I'm able to push the image. I can push v1, I can push v2. Both the versions I can push. Little slow. Okay, there was some internet disruption, but hopefully it is rectified now. You should be able to. So the image is being pushed from my machine. We are able to push an image into the registry. A bit slow. As it is uploading, can I request you to see that if you are able to like this video or subscribe to the channel. I'm going to conduct back-to-back sessions, Docker, followed by that next week I'm planning to do something on microservices architecture. Certain things I'll do on Kubernetes, some things we'll do on Azure, Python, multiple back-to-back sessions you can see from my side coming now. So if you're interested in getting notification, I would suggest subscribe to the channel and also hit the bell icon so that you get the notification. Please don't forget to like the video and probably also share with your colleagues in the organization. I'm telling you, this will be one of the best and the simplest content they would have ever seen on containerization. Very good beginning for anybody with only the basic knowledge of programming. Of course, this is not very systematic. There is definitely a complete course offered which is very systematic, but this is good enough. Now you see I'm uploading V1 also, and V1 okay doesn't exist because that was not tagged. So V1 here, V1 here. So it tagged it. Push V1 too, and this will go fast because only one layer will be different. My code layer, the base layers all should be ready. Just the code which I wrote, that's the difference. And now if I go to Docker Hub and refresh, I should see a Sandeep Soni / my web app. This is the repository. Under this repository, I click on that. I'll see there are two images, V1, V2, which are Linux based. And what we can do, actually these images are public now. If you want, you can do Docker pull and pull those images. Let me demonstrate that to you. So I'll do Docker ls or Docker image ls. I'll do RMI my web app :v1 remove, v2 remove, Sandeep Soni / container is running. So let me stop the container. Docker stop bf and Docker container. Actually the containers are in exit state. I'll remove all these. Docker container prune. A lot of these commands we are supposed to learn. I'm not able to teach, time constraint. Docker ps or Docker image ls. We still have one more, v1. Let's say v1 gone. Now if I do Docker image ls, you see we don't have that image anymore. What can I do? Do Docker run. or Docker pull Sandeepsoni slash my web app colon v1, the image will get downloaded. Actually, if you are having Docker on your machine, you can try the same command at this point and it will work. Same thing I'll do for Docker v2. The layers are almost all there except the last layer. Now if I type Docker image ls, I see those images. And because those images are there, I can directly do run the container. So net, in this particular session, I have shown to you how is containerization going to become popular because of its benefits. And we have also seen how we can run a container from the image. And also we have seen how we can create our own custom image, push it to the registry, pull it from the registry. Mind you, this is just a gist of the entire training which we give on Docker. So there's a detailed course on Docker. These are the courseware which I use. All these are different handouts. There are different topics which we take in Docker. You can actually go to 𝗙cie_h'𝗙𝗴𝗲𝗁 and here we have got some mock exams in which I did upload few things related to Docker. I think they are in I don't see, maybe my team has removed it. There was an exam on Docker. Maybe I'll ask them to upload it here. You should be able to see a small test which you can write on Docker over here. Like you can see a lot of other certification exam question banks. Azure majorly Azure platform, Microsoft platform. But you will also be able to see Docker over there. So do visit this website and look at mock exam later if you get a chance. And yes, you can also visit our website best.training.com and you'll find there a complete course on Docker. Entire course is there. Introduction to Docker, getting started with Docker commands, Docker images, multi-stage builds, bind mounts, networking, Docker compose, Docker registry, everything is there. So this can be of real great use to you if you want to start your Docker journey. You can get back to my team and maybe look forward. If you have enrolled for this particular course, you'll also be able to attend the live sessions which I'm going to start. Docker and Kubernetes, I'm starting live session on July 12th. That will be morning 7:30 to 9 a.m. Total course will be for 45 days, including both Docker and Kubernetes. This course will also help you for CKAD exam, Kubernetes Certified Application Developer, which is very popular, has a lot of value when compared to probably any other exam. I will ensure that you get through it 100% if you're part of this particular training. So in case you're interested, you can join this. Ask for my team to give you some early bird offers if you're not a gold member. Yes, if you're already a gold member, this comes to you absolutely at no additional cost. It's a part of gold membership package or other packages which probably you might have enrolled for. So those who are coming to Deccansoft for the first time, I would request you to look at all the different packages which are available on our site. so that you can enroll and start your technology journey in upskilling yourself with us and feel confident about it. I would request you to leave your comments on how was this particular session. Because of some time constraint, next meeting I will not be able to take questions today, but I'll try to see if I can answer to your questions in the WhatsApp groups if you are a member, or you can also post it to me personally, taking my details from site. I'll do whatever best in the interest. You can take my number from here, post me the question, or if you are in the WhatsApp group, just tag me and post the question. In my capacity, whenever I get a chance, I'll try to reply. Said all this, see you very soon for next upcoming webinar. Keep an eye on this particular series over here. There will be some schedules coming up here very soon, and you can attend. Thank you and best of luck. Bye-bye. Take care.